So now let's talk about decision trees. These are actually very amazing. They're very easy to make, very easy to understand, and surprisingly effective. So first you make a fake data set just so we have something. Oh, this is a real data set. This is a famous machine learning data set. It is a bunch of measurements of irises. There are apparently three different types of irises, and they vary in things like their petal length and other measurements. So there's 150 instances, 50 in each of the three categories of irises. And so you import the irises, and now you make a decision tree classifier. And a decision tree classifier is just a series of if statements. So you choose how deep to make the decision tree. Maximum depth equals 2. And here's what it does. If the petal length is less than 2.45, then it's true, you go over here. If it's false, you go over here. Then if the petal width is less than 1.75, it's true over here, false over here. That is 2 layers deep, 2 layers of if statements, and that's it. And the colors indicate the classes. And now you can measure the efficiency. There is a thing called the Gini coefficient. The Gini coefficient is the measure of disorder or entropy, if you like. Notice this single if tree 100% sampled this. All 50 of the Satoshas are here. So that has a Gini coefficient of 0. But over here, you had 50 of one class versicolor and 50 of virginica. So your Gini is 0.5. That's the mathematical measure. You've got a lot of multiple data types in this box. So when you split it again, it puts 49 of versicolor and 5 wrong here. And over here, it puts 45 right and 1 wrong. So both of these are pretty well sorted, but the Gini does not go to 0. It's 0.16 and 0.04. So that's one way to measure it. And the thing about this, of course, is it's very easy to understand. If you decide you don't like something, you can easily see, just change some of these if statements. It could have been written by a human. And so now you can display the predictions on 2 dimensions. You split it this way and you split it that way. That's the prediction. So this first split was 100% successful at picking these out, but the second split was only moderately successful at separating these 2 types. So I can do another one with depth 3 and see how it works, and so on. So now we're going to make this data set with curve and noise that we've used before. You can fit curves with decision trees. What you do is you run it, and it will now have various layers. Now, if it's only 2 layers down, it's going to do this. It's going to make a real approximate stepwise attempt to follow the curve. That's what it can do with just 2 layers of if statements. You can then go to layer 6, and now it's getting pretty good at stepping through that curve because it can have basically up to 32 levels here. It's essentially analog to digital conversion is another way to look at it. And you can do it with unlimited depth. And now it severely overfits the data. This is what I've talked about before. This is like the mathematically perfect fit. If you don't have any regularization, is to just spike every point. So it will perfectly fit the training data, but when you feed it test data, it will be much worse because it's not really finding the trend and ignoring the noise. It's also fitting the noise. Now, this is something that happened to large language models. When the popular large language models like ChatGPT came out, they found out they trained them on all this data they scraped from the internet without getting any permission. And people with published work started asking, did they train it on my science fiction book? I know, I'll just type in the first couple of paragraphs of my book and see what happens. And if you do that, it will repeat page after page exactly verbatim of the science fiction book. And the same thing for New York Times stories. And New York Times is now suing OpenAI, saying you stole our data. Now, OpenAI is saying, no, we performed fair use on your data. Now, you put it on the internet without a paywall, saying humans can read this and learn from it. And all we did is our AI read it and learned from it. Their argument is all the AI did was learn how to write good English by examining the English you wrote, which is what you thought people would do. But the New York Times says, no, what your AI did was memorize it and then repeat it verbatim to people without us getting any royalty. And that's stealing it. And this is the issue. I'm sure the legal issues will be more subtle than this, but from a technical point of view, if the AI is overfitting, then it is in fact just stealing the input data. And if it's not overfitting, then it is just learning the trend from the input data. So both of those are issues, and all the public LLMs do obviously at least sometimes suffer from overfitting because they will repeat training data verbatim. And this is a security issue too, because remember the question I brought up in the opening lecture in the WASP 10 top 10 security risks. The question is, if I ask a question of Gemini, is it going to leak that back out? And apparently, under some circumstances, it does learn from the data by perfectly memorizing the data. So it might just repeat whatever I typed in to another user. So that's an issue. And there's a movement to try to develop interpretable AIs where you can understand what they're doing and you can adjust what they're doing to deal with these effects. But that's just in its infancy right now. And it does bring us to another question, which is real important. Suppose the New York Times wins that lawsuit. They say, you can't use any more New York Times data. Well, now that you've trained a large language model, which takes a huge machine with thousands of graphic cards, and it costs $40 million to train it, how do you remove some of the training data from the model? This is currently an unsolved question, an area of research. There are people that try to develop it. I mean, the only sure way would be to retrain the model on a new data set, having removed the data you don't have the right to use. But that would be really expensive, especially as after the New York Times does it, everybody else is going to do it. You're going to have hundreds of lawsuits, and you're going to keep wanting to erase data. And now the European privacy laws say that if anybody gathers your data, you have the right to demand that they show you what data they have and that you can ask them to delete your data. So they're going to be getting requests from individuals. I want you to delete my data from Gemini. And how can you do that? These are some of the big thorny questions that there aren't any good answers for right now, but they're all going to come up over the next couple of years. Maybe I'll stop this one.